Elementary Algebra, Assessment 3, Review, questions 15 through 20. For question number 15, the instructions read, multiply the binomials using the FOIL method. The F in the FOIL method stands for multiplying the first two terms. So we multiply the 3x times the x, so we get a 3x times x. The O stands for multiplying the outer two terms. So we're going to multiply this 3x times this negative 11. So I'm going to carry that down here. I have a 3x times a negative 11. The I stands for multiplying the inner two terms, so a negative 2 to an x, so I carry down a negative 2 to an x here. And then the L stands for multiplying the last two terms together, so the negative 2 to the negative 11. So I have a negative 2 to a negative 11. So when I clean that up, a 3x times x makes a 3x squared. Then I have a 3x times a negative 11, that makes a negative 33x, or minus 33x. Then I come over here and I have a negative 2 to a positive x, so that makes a negative 2x, or minus 2x. And then lastly, I have a negative 2 times a negative 11, which makes a positive 22, so plus 22. My next step is to combine like terms. The middle two terms are alike. They have the same variable raised to the same degree. So a negative 33x plus a negative 2x makes a negative 35x. So once I've combined the like terms, I'm done. Question number 16 reads, multiply the polynomials. So this is going to be similar to the previous one. I'm going to make sure that the first term here distributes to every term in the second polynomial. So I'm going to take that x and multiply it to that 7x squared. I'm going to take the x and multiply it to the x. I'm going to take the x and multiply it to the 7. Once I've distributed that x to each of the terms in the following polynomial, I move to the second term, which is the negative 3. I'm going to multiply the negative 3 to the 7x squared, multiply the negative 3 to the x, and then multiply the negative 3 to the 7. So this is what the result is. Let's clean it up. So a 7x squared times an x makes a 7x cubed. An x times an x makes an x squared. A 7 times x makes a 7x. A negative 3 times a positive 7 makes a negative 12x squared, plus my negative 3 times my x, so a negative 3x, and then lastly, a negative 3 times a 7 to make a negative 21. My next step is to combine like terms. I don't have another 7 or another x to the third, so I'm just going to carry down that 7x to the third. The x to the second. When I come over here, I've got another x to the second over here. I have a positive 1x to the second here, and a negative 21x to the second here. Combining those makes a negative 20x to the second. So I come down here and I write minus 20x to the second. So those two are done. I move on. I see I have a 7x. I look to see if I have another x. I have a negative 3x, so I'm going to combine these two. That's going to result in a positive 4x, or plus 4x. Lastly, I'm left with just the negative 21. There's nothing to sum to it, so I'll just carry it down. So I end up with a minus 21. Moving on to question number 17. It says, multiply using the rules for special products. Well, when I look at this one, I have a 3x plus a 12 with a 3x minus a 12. These are conjugates to one another. The rule says that when multiplying conjugates, if a and b are real numbers, variables, or expressions, then a plus b times a minus b is going to be equal to a squared minus b squared. So knowing that, I'm going to take those bases. My a is my 3x, so I'm going to take that 3x and I'm going to square it, as the rule suggests, minus what's in the b position, which is a 12, raised to the second power. So cleaning that up, bring the 2 in on the 3, bring the 2 in on the x. So when I bring it in here on the 3, I get a 3 times 3, which creates a 9, x to the second power, and then Bringing that 2 in on the 12 means that I have a 12 times a 12 for 144. So I have a 9x squared minus 144. Moving down from there, on number 18, I'm going to use those rules that I was given above. So I have a 3x minus 8x raised to the second power. Now this time what I have is a binomial that's actually squaring. I have the 3x minus 8x, which is my binomial, and it's being squared. If this is the case, then if a and b are real numbers, variables, or expressions, then I can use one of the two formulas down here, depending on if I have summing or subtracting in the binomial. I have subtraction in the binomial, so I'm going to use the second one down. So it says to take what's from the a position first and to plug it in. So I end up with the a position, the 3x squared, plus 2 times what's in the a position, which is the 3x, times what's in the b position, which is negative 8y, plus the b position squared, which is the negative 8y squared. And I just need to complete the math. I bring the 2 in on the 3 and the x, so I end up with a 3 to the second power, x to the second power. When completed, that creates a 9x to the second power. Then I'm going to take the 2 times the 3 times the negative 8, which makes a negative 48, and combine the x and y behind it. So I get a negative 48xy. Lastly, I'm going to pull that 2 in on the negative 8 and in on the y. So I end up with a negative 8 times a negative 8 to create a positive 64 y squared. Number 19, its instructions read, divide the monomials. So I'm going to come in here and I'm going to divide these things in. Before I do though, just so that it makes it easier to view, I'm going to pull the constants and the variables apart from one another. I'm going to separate them. So down here what I've got is a negative 3 over 18, so those are my constants here, times, next I pull my x's with one another, so x to the 6th over x to the 5th, times the y divided by the y to the 2nd, times the z. I don't have a z in the bottom, so I just put that z over a 1. Now I can come through here and finish the math. Well, 18 is not going to divide into 3 evenly, but I can do some reducing. So I know that a 3 will go into 18, so 3 goes into 3 one time, and 3 goes into 18 6 times, creating the negative 1/6. Moving on to the x's, when it's division, I subtract the exponents, so a 6 minus a 5 leaves me with an x to the 1st degree, so a 1. Moving on to the y's, I have a 1 minus a 2. That leaves me with a negative 1. And then just copy down the z over 1. It doesn't have anything special that I need to do to it. Now before I pull these back together, and the reason I pulled these apart was in the event that I created a negative exponent on any of them. And I did that on the y. I have a negative exponent. And we learned from our rules that if we simply flip this thing over, take the reciprocal, that the negative sign will disappear. So I just need to flip this over and it becomes a 1 over y. Now the negative's gone. Now I'm ready to multiply across. I have a negative sign, so I'm going to make sure that I carry that negative over here. And then I have a 1 times an x times a 1 times a z. That makes xz. Then I have a 6 times a 1 times a y times a 1. So I'm left with 6y for my final answer. Moving on to question number 20, it says, use long division to divide the polynomials. So up here, I'm looking at this. I have this polynomial that has 4 terms in it, and it's being divided by a binomial, r minus 2. So I'm going to set this up as a long division problem. The r minus 2 to the outside, it's the one that's dividing, and my polynomial to the inside. Now I need to decide what's going to be my first value that I pull out. Well, I do this by looking at the first value to the inside. In this case, it's the 5r to the 3rd. I'm going to write it over here on the side just a little bit. And then I'm also going to pull the first value to the outside on that binomial, which is an r, and I come down here and I divide that value into that other value. So a 5r to the third divided by an r results in a 5r squared. Remember, a 1 divided by a 5 is just 5. An r to the third and an r to the first, when it's dividing, just subtract. So 3 minus 1 leaves me with an r2. So I come back over here. This is going to be my first number that I'm going to distribute. So I have a 5r to the second. I'm going to write it up here. And now I'm going to distribute it to each of the terms that I see on the outside. So 5r squared times an r makes a 5r cubed. Stop there. On that first multiplication, if you're not going to come down to a 0 when you subtract them, that means that they're identical, then you need to go back and recheck your math, because every time this first position should 0 out. So now I see they're the same, so they're going to 0 out, so I'm fine. So I'll move over, distribute the other one. So 5r to the second times a negative 2 makes a negative 10r to the second. And I draw my line under there, and just like traditional long division, I'm going to subtract the second line from the first line. So this is going to be a 5r cubed minus a 5r cubed, which results in 0. This is going to be a negative 7r cubed minus a negative 10r cubed. So I have a minus to a negative, so this 10 becomes a positive. So it's a negative 7 plus a 10. They're opposite, so we subtract, we get a 3. The larger turned out to be positive, so this is a positive value. Carry down the r squares. Now again, start over from the beginning, the same rule. Take that first position here, so it's the 3r squared down here. Pull it out. I'm going to put it over here to the side. Then pull the first position on the outside of the binomial. I'm going to pull it over here to the side, put it under there, and I'm going to divide that r into 3r squared, and I get a 3r. And it's a positive 3r, so I put a plus 3r up here. And I distribute it. 3r to r makes a 3r squared. Again, stop. That should come down to a 0. If it doesn't, then you need to go back and recheck the math over here on the side. That first position should always go down to a 0. Now I can come over here and I can take the 3r to the negative 2. That makes a negative 6r. So again, subtract down. We already know that the 3r squared minus the 3r squared makes a 0. The negative 3r minus the negative 6r. So I have a minus. I'm subtracting my negative 6r here. That makes this a positive. So I have a negative 3r plus a 6r. Makes a positive 3r minus 6. Or excuse me, positive 3r. So now I'm ready to pull down the next value, so it's a negative 6. So I take the first position again out here, bring it over here, put it to the outside, so I've got the 3r divided by the first position on the outside here, r. So a 3r divided by a 3r divided by an r creates a 3. It's a positive 3, so I come up here and put a plus 3, and I distribute it through. So 3 times r to make my 3r, 3 times my negative 2 to make a negative 6. I check that first position, 3r minus 3r made a 0. I'm good there. Now I come over to see if there's going to be any remainder. I have a negative 6 minus a negative 6. So this is going to be a negative 6 plus 6, which results in 0. I don't have a remainder on this one. So the values that I see up here in the top is going to be my final answer. If I had a remainder down here and I had nothing else to pull down with it, that remainder would then be brought to the end, and it would be placed over the original divisor. So it would be summed to the end, plus whatever the remainder is over the original divisor, which in this case the divisor was r minus 2. That would go in there. But we didn't end up with a remainder on this one. So the final answer is 5r squared plus 3r plus 3.